Hi, in this video, I'm going to discuss about normalizing the features. What is the meaning of normalization? How we are going to perform the normalization on the given data set. So here it is one of the important pre-processing step in the machine learning process. Okay, machine learning process. Okay, so here, for example, here we are giving that some data set like x1, x2, and xn, x3. These are the some of the features. Okay, and corresponding class label. These are the different information is there. Okay, now so here the data may be in the form of a different categories, different values are there, like in the form of a one is in the form of 0, 1, 2, 3 like that, and some are in the form of a high values like 10,000 and 20,000 and 40,000 and some on the 50,000 like that. Okay, and also x3 is nothing but in the form of a suppose 20, 30, 40 and 50 like that. We're having some different range of values are there. Okay, and here the corresponding class label is a, suppose this is a class label is equal to 1 and class label equal to 3, class label equal to 4. So these are the different data sets are there, different values for the each and every feature is there. Now here you see this example also, income is in the form of a one range of values are there. Okay, like 41,100 and second instant is 54,100, 47,800 and 19,100. Like that, we're having different income values are there. But coming to age group, here it contains 48.75, 28.10, 46.75 and 40.25, 35.80. All these are called as features. Is called as features. Feature 1 and feature 2. Feature 2. So here also we are having the different features are there. If in order to perform the machine learning work well on our data set, all the features must be the same range of values. Then our machine learning is going to be work very well on our given data set. If the range of values here in between the, for example, here the range of values of x1 is between the 0 to 3, and here the values between the 10,000 to okay 50,000, and here the range of values between the 20 to 50, and the value. Okay, so here compared to all the features, what happened? This is a small range of data is there, and here the range of values are very high, and this range of values is somewhat medium. Okay, so at this case, or if you apply the machine learning concepts on this data set, is unable to perform very well on this data set. So in order to avoid that one, we are going to apply some concept called as a pre-processing step. One step is called as a pre-processing. In the machine learning, the first step is we call as a pre-processing. So in the pre-processing, there is one more step is that is called as a feature scaling. There is one more step is called as a feature scaling. Based on the feature scaling, we are going to convert all the feature values into some range of values between the all the feature values convert between the 0 to 1, okay, or plus 1 to minus 1, okay, and plus 2, minus 2 to plus 2, like that. All the feature values are converted between the some certain range of values. So simply that process is called as a feature scaling. Okay, after performing the feature scaling, then we are going to apply our machine learning algorithm on the scale data set. Our machine learning will give the better results. Okay, we will see step by step process here. For example, here this is our data set. Our data set is income data. In the income data, we are having the income feature and age field is there. Here income has a different range of values and age contains a different range of values. Okay, suppose if you apply some machine learning algorithm, this data set is unable to perform very well. So in order to avoid that one, we are going to apply feature scaling. So ML algorithms do not perform well on the input to numerical attributes have very different scales. Okay, that means there are, if input to numerical attributes have different scales of data is there, at that time is unable to perform well. So feature scaling is one of the most important technique or transformation we need to apply on our data set. Then you can apply the machine learning algorithm. Then our algorithm is going to work very well on our transformed data set. So that means here the feature scaling is nothing but a converting the original data into different transformation. Okay, simply this process is called as a feature scaling or a feature transformation. Feature transformation. Okay, so there are there are different ways are there. Okay, in order to perform the feature scaling, that is one technique is called as a min max scaling and standardization. So min max scaling is also called as a normalization. It's also called as a normalization. Okay, normalization. And the second technique is called as a standardization. So we can apply either min-max scaling or standardization process on our data set in order to convert the original data into scaled data. Okay. So here we'll see the first technique is called as a min-max scaling. This is also known as a normalization. So normalization values are in the range between the 0 to 1. The normal values are between the 0 to 1. So for example here the data in the between the minus 100 to minus 50, 0, 50 and 100. This is the original data. On this data we are going to apply the normalization technique. Okay, then our original data is converted into normalized data, that is in the range between the 0 to 1. Okay, so 0, 0.0, 0, 0.2, 0, 0.4, 0, 0.6, 0, 0.8 and 1.0. All the data is converted between the 0 to 1. Simply this process is called as a min-max scaling or normalization technique. So here there is one formula is there, that is called as a normalization formula. So x dash equal to that is called as a normalized value for the given instance, given particular variable equal to x minus, that is original value, minus min of x, entire column, entire feature minimum of x value by max of x minus min of x. So that gives the min max scaling or normalization value. So here, for example, we are going to see one example itself of for the min max scaling. So here we are going to create the one data frame. Okay, first of all we are going to create the one data frame. So for that we are going to import the pandas as PD, and we are going to create a one series of data. Okay, S1 equal to PD dot series of data between the 1, 2, 3, 4, 5, 6. This is a column data. The corresponding column name equal to S1 and index equal to range of 6. So 6 elements are there. Okay. Now we are going to create one more series of data, that is just equal to PD dot series of 10, 9, 8, 7, 6, 5 and index equal to range of 6 value. So S2 is a one type of series and S1 equal to one type of series of data. S1 contains starts with 1 to 6 and S2 starts with 10 to 5. Okay, this is our example data. On this data we are going to this is our series of data. Then we are going to create a one data frame. That data frame, first of all we have to create the PD dot data frame of S1 columns equal to S1. That means we are creating one data frame. On the data frame the first variable equal to first column equal to S1. The column name of that S1 equal to S1 only. Okay. And then we are going to add one more column to the our data frame, that is df of S2 equal to S2. So already we create the series S1 and S2. Those series of data is added to the data frame. If you display the data frame, automatically it will display the data like this one. So on this data set, we are going to apply our min-max scaling. So here min-max scaling is for example here. So for example, we'll see the for the series S1. So what the first instance, suppose we are going to create our first variable, that is S1 dash for the one dash. Okay, for the one variable we are going to change the value. How we are going to perform that one? So that is equal to what the initial value 1 minus what the minimum of entire column, that series 1 only. Okay, 1 minus 1 by, okay, what is the maximum value? 6. 6 minus 1, that is equal to 0 by 5, that is equal to 0 only. That means after performing the normalization scaling, they are getting the value equal to 0.0. Suppose if you see the 2 dash, that means for the second variable, how we are going to get the value is 0.2. So what the x value, that is 2. 2 minus what the minimum of the entire column? 1. 2 minus 1 by 6 minus what the max of x, entire column of max equal to 6 minus what the minimum of entire column, that s1 is equal to 1, that is equal to 1 by 5. 1 by 5, that is equal to 0.2. So that the value of 2 is replaced with 0.2. Like that we are going to convert all the variables, all the instances in the corresponding column into normalized form. That is called as a min-max scaling. So this is the formula: x dash equal to x minus of min of x by max of x minus min of x. So with the help of scikit-learn also we are going to convert that into with the help of simple program we are convert the original data into transformed scaling data. Okay, so here use the scikit-learn min-max scaling function. We are going to convert that into normalized form. So from the ML extend dot preprocessing import min-max scaling and perform the min-max scaling. So for that we are going to provide the data frame, and for the columns, so S1 comma S2 we are going to perform the min-max scaling. Then we are going to get the different values. Okay, like that we are going to get these are the values. So this is the original data set and corresponding scaled value equal to between the 0 to 1. So whatever the values are there, 1, 2, 6, all the values are converted between the 0.0 to 1.0. If you take the second series of data, so the max column is 110 and minimum value equal to 5. Whatever the data is there, that is converted between the 1.0 to 0.0. Okay, simply this process is called as a min-max scaling or normalization. Then we are going to see the other technique is called as a standardization. So here we are having the various types of data like audio signals, pixel values of for image data, and this data can be included multiple dimensions. So at that time we are going to apply the concept called as a standardization. So the general method for calculation of calculate the distribution mean and standard deviation for each feature. So you have to find out the first of all you have to find out the mean value for the entire features and corresponding standard deviation. Based on this information, we are going to find out the corresponding standardization. Okay, now so here the main thing is we have to find out the mean of the mean and standard deviation for each and every feature. That is very, very important. Okay. Now subtract the mean from the each feature and divide the results from the previous step of each feature by its standard deviation. That is equal. That is x dash equal to, that is a standardized value equal to x minus of x bar by sigma. That is x is nothing but corresponding element value minus x bar is nothing but our mean value, sigma nothing but standard deviation. By applying this concept, our data is going to be converted between the -1 to +1 or -2 to +2, that range of data. Okay, simply this process is called as a standardization. Now standardization features are rescaled so that the output will have the properties of a standard normal distribution with zero mean value and unit variance. So here the zero mean x dash equal to x bar equal to 0 and sigma equal to 1, that is mean equal to zero mean value and unit variance. Simply that is the after applying the standardization, that is the value we are going to get. Okay. Now if you want to implement that one, scikit-learn provides some library file. Based on that library file, we are going to implement that in our program. We can easily convert the given data into scale format by applying the standardization. Okay. So standard scalar class for the standardization. Okay. For example, here min-max scaling is in the range of 0 to 1. Min-max scaling is in the range of 0 to 1, and standardization does not bound values to a specific range. It may be problem for some algorithms. Okay, example of neural networks expect an input value ranging from the 0 to 1. The input value range from the 0 to 1. Okay, so we will learn more use cases as we proceed in the course. Okay, in the meanwhile we will see that what are different types of standardization and min-max scaling in our course. Okay, so here we will see one example, standard scalar. Okay, in sklearn dot preprocessing. So a standard scalar present in the sklearn dot preprocessing that normalizes our data. Okay. So all values by subtracting the all the values from its mean value and divide by its standard deviation. Already you know what the meaning of x dash equal to x minus mu by sigma. So this is our standardization. Okay. So now here that is the x normalized equal to xi minus x bar by sigma of x, where x bar is the mean of the x and sigma of x is the corresponding standard deviation of x feature. So with the help of this one, we are going to apply this standardization and normalization on our data set, that is income data dot csv. Okay, on this data set, so it contains only income and corresponding age groups are there. On this data set, we are going to apply the first step is feature scaling or normalization. Feature scaling is going to apply on this data set. On that data set, we are going to apply our model, that is a k-means algorithm. Okay, in order to find out the corresponding cluster ID of our data set. Okay, so here normalizing features. Standard scalar is available under the sklearn dot preprocessing module. Okay, so import and initialize the standard scalar and pass the data frame to fit the method to transform the column values. Okay, first of all you have to import the standard scalar and initialize the standard scalar and then pass the standard data frame to our fit method. Automatically it transforms the column values into other format. So here we see the data. Okay, so the initial data set is a data set of name. This is a income data dot csv. Okay, dot csv, that is already present in the some data frame. Okay, so from the sklearn dot preprocessing import to standard scalar. Now scalar equal to standard scalar, that means we are going to initialize our model. What is our model? Standard scalar is the model that is going to be assigned to scalar. Okay, and then we are going to fit underscore transform on the scalar. Our model is a scalar dot fit means train the model and transform. What is the meaning of transform? After fitting, automatically you have to convert that into other format of data. Okay, for the customers underscore df, the dataset name is equal to here customers dot hyphen df. It contains all the income data csv file with the corresponding class label features are column name as age and income. Okay, now after applying this one, what happened? That the data is going to be transformed into scaled format. Okay, so the transformed scale format data set name is equal to scaled underscore customers underscore df. It contains the converted data, that is a scaled data, not the original data set. Okay, now if you display the scale underscore customers underscore df of 0 to 5 rows. Okay, I display the some column data like here. See this one. First of all, if you get the data here, this is the income group and income and this is the age. Okay, now if you see the here we are having the 41,100 is the our income and age is 48.275. Whatever the data is there, all the data is converted between the minus 2 to plus 2 range of data. Okay, so here the income is 1.37 and 0.09 is okay, minus 1.37 and 0.96, like that all the data is converted between the minus 2 to plus 2 range of data. So simply this process is called as a standard scalar. So now we get the difference between the what is the difference between the original data set and the scaled transform data set. Okay, now we can create the clusters again using the normalized feature set. Okay, in the previous video we discussed about the without applying the feature scaling. Okay, on original data set we are applying the clustering algorithms, So it enables to perfect the give the class level for the given data set perfectly. So in order to avoid that one, we are going to in this video we are seeing that we are applying the normalized feature on the given data set, and then we are applying the clustering algorithm. So from the sklearn dot cluster import the k-means algorithm. We are going to import the k-means algorithm from the sklearn dot cluster. So cluster underscore new equal to k-means. Our algorithm is k-means. K-means of 3 comma random underscore state equal to 42. So that means here we are going to create the 3 clusters for the given data set, and the clusters names are equal to this is your corresponding class labels. Okay. Now if you display that one, okay. And this is our model. What is our model? What is our model? Clusters underscore new. That is our k-means algorithm. It implements the number of clusters. So now this method is going to be trained with our data set. Okay, that is clusters underscore new dot fit. Fit is the method to train our data set. Okay, so here we are providing the data set is a scaled underscore customers underscore data frame. That means here our data set is a converted the data set or transformed data set, not the original data set. Okay, so customers underscore df. Okay, and we are going to create the one more variable that is called as a cluster id underscore new. Okay, that is equal to clusters underscore new dot labels. By applying our clusters cluster method on our data set, we are going to get the output in the form of a clusters underscore new dot labels. We are getting the labels. Those labels are going to be added to our customer underscore df data set. Okay, to clusters id new column name. Now you should display the clusters underscore new and dot labels underscore equal to. Okay, we are getting the new labels for the all the data set. It contains 300 features are there, 300 instances are there. Okay, so our data set contains income and age. It contains 300 instances are there. 300 instances are there and 2 features are there. So corresponding model, we are having the cluster IDs are there. Cluster IDs are cluster. Or we are going to create one more ID variable called as a cluster ID based on the our k-means clustering algorithm. So we are getting the 300 into 1. So that means we are getting the corresponding cluster IDs for each and every instance. So we are having the 300 corresponding cluster IDs. Okay, like 0, 1, 0, 2, 2 like that. These are becomes the cluster IDs for our given data set. So here our number of clusters equal to 3. So here the cluster IDs are starts with either 0 or 1 or 2. All the 300 variables are 300 instances are assigned mapped to any one of the cluster ID like 0, 1 or 2. Then the new segments created can be plotted using the scatter plot and marking each segment differently. So here the markers are plus and cap and dot symbols are there. Okay, sn dot im plot age is our first variable. Age is on x-axis and income on y-axis, and the corresponding data equal to customers underscore data frame, and hue equal to that is color format of that data set equal based on the cluster ID underscore new based on new data set new cluster IDs. We are going to assign the class corresponding color, and fit underscore regression equal to false, markers equal to markers, size equal to 4. So here this is our representation of our data set. Okay, here all are belonging to one color and these are all are belonging to some other color here. Okay, and this is one cluster. We are having 3 clusters for our given data set. Okay, so this is one this is a cluster ID equal to 0 and this cluster equal to 1 and this cluster ID equal to 2. We are created the 3 clusters. Okay, it's a different things. Now, so see the difference between the without normalization or standard scalar and with standard scalar. So here this is the without okay standardization. without standardization or without normalization, and this is with normalization, with standardization. We are applying the standardization on the our data set, then applying our cluster algorithm. So see the difference here. Before applying the that means without applying the standardization on our data set. So here this is one drawback here. This is one drawback. Okay, these elements are very close to this cluster, but we are unable. We are creating the we are marked as a another cluster. Okay, that is the drawback because of we are not applied the standard scalar. But whereas here we are applying the standard scalar, all the elements are in this group are called as a only single cluster only. See the different. Here this is a this is one separate group is there, and this is a separate group. Okay, and here these elements are very close to plus symbols, but we are unable to create the combined to single cluster. Okay, this is because of we are not applied the standardization. Here after applying the standardization, what happened? All the features are converted to standard scale. Okay, some uniform values are there, so that we are getting the all the elements are very close to each other. So that means these elements are also belonging to same cluster. Okay, that is the way we are going to create the that is the importance of the standardization. Okay, so now the cluster seems that it has been created properly. The cluster centers are given by the clusters dot cluster underscore centers. Okay, underscore. So these are the we are creating the three clusters. So the first cluster center equal to income and corresponding age. Okay, like that. Okay, they are the different features for the center for the all these clusters. This is a center for the first cluster, and this is for the second cluster, and this is the for this third cluster. Okay, this is income and income value after applying the standard scalar. This is the age value. Okay, now the clusters on dot clusters underscore centers, then we are going to get the standard values are there. Hence we can calculate the cluster centers from the original data frame using the information which customers have been allocated to which segments. Okay, so like that we are going to apply the standard scalar on the original data set. Okay, then only we are going to apply the clustering algorithm on our data set, so that our algorithm is going to be perfectly provide the corresponding cluster ID. Okay, so this is about the normalization of the features. Okay, in the next video I am going to discuss about the other topic. Okay, if you have any doubts, any questions are there, please leave them in the comment section. In the next video I will going to discuss those things. And thank you for watching our video. If you like the video, please subscribe my channel. Thank you.